Okay, so this is dy. Here, you could replace this with dy dx. So this is a differential equation that we call separable because you can multiply that dx to both sides, and you can get one side entirely in terms of y and one side entirely in terms of x. Oftentimes, differential equations, you can't do that. They're tangled up with one another. Oh, I forgot the y, 4y. And we need different techniques in that case. But these are separable. So all you have to do is multiply that 4y to both sides. And then you can integrate both sides now that we have one side with respect to y and one side with respect to x. So on the left side we get 4y squared plus an arbitrary constant c, and I'll call that c sub 1 because we're going to get another arbitrary constant in just a second. And then here, if I factor out that negative sign, the antiderivative is going to be, let's see, x to the fifth, because then the derivative would turn into this. And it's minus 5x, because the derivative would turn into this. And then plus a different arbitrary constant c. And we can combine the arbitrary constants because one arbitrary number subtracted by another arbitrary number is just a different arbitrary number. So I'm going to put plus a constant c here. So we got negative x to the fifth plus 5x plus that arbitrary constant. And the goal is to solve for y, so I'm just going to finish out the algebra here. Y squared is negative x to the fifth plus 5x plus c over 4. And that would just be a new arbitrary constant, but we can leave it like that too. And then you need to take a square root to cancel out a squared. We just need plus or minus. Okay. Whoops, I missed something. The integral of 4y is 2y squared, so this should be a 2. This should be a 2. Sorry about that.